Let's take a look at example 3. We have an application. So we're given a position function. S of t gives the height in feet of a model rocket above the moon surface t seconds after liftoff. The instantaneous velocity, v of t, is defined to be s prime of t. So s gives us how far off the ground we are at time t. V of t is going to give us the velocity at time t. And remember, velocity gives us not only the speed, but also the direction, going, in this case, up or down. So we're asked to find a formula for v of t. So v of t is the derivative s prime of t. That's going to be the limit as h goes to 0 of s of t plus h minus s of t divided by h. So our s of t is minus 5t squared plus 100t. So s of t plus h is, everywhere we see a t, either literally or in our mind's eye, we're going to envelop that t in parentheses. We're going to erase the t and replace it with the t plus h. So this is where a lot of the mistakes happen, but if we just follow those rules, we'll be fine. So now we have to, order of operations says we got to square out the t plus h before we multiply by the negative 5. So we'll do that. And once again, when in doubt, write it out. T plus h quantity squared is t plus h times t plus h. And now you go through the multiplication there. T times t is going to give you a t squared. You're going to get a t times h and another t times h. So you're going to get two of them. And then you get an h times h, which is an h squared, plus 100 t plus 100h because of the distributing there. And now we would multiply through the negative 5. So I'm going to end up with a negative 5t squared, a negative 10th, a negative 5h squared, plus 100t plus 100h. And so that expression goes in for the s of t plus h. So now we're off to that. So v of t is s prime of t. I'm just going to recopy this limit. Limit as h goes to 0. S of t plus h minus s of t divided by h. And now what we need to do is replace our expressions for s of t plus h and s of t. And remember, you can always replace using parentheses. Right? So don't be shy about using parentheses here. So let's go ahead and plug in what we had for the s of t plus h, because it was quite a production here. It was a minus 5t squared minus 10th minus 5h squared plus 100t plus 100h. So this whole thing is the expression for s of t plus h. Now from that I have to subtract the formula for s of t. Maybe I'll use a different color brackets here. Maybe I'll use blue just to set it off a little different. S of t was minus 5t squared plus 100t. And so this is our s of t. Note the parentheses, and this is all divided by h. Now in order for us to determine this limit, we're hoping that everything in the numerator that doesn't have an h in it will cancel out and allow us to factor an h out and then cancel it from the denominator. So let's see what happens. Got limit as h goes to 0 of we can remove the parentheses. Minus 5t squared minus 10th minus 5h squared plus 100t plus 100h. And here's where it's really crucial we have these parentheses. So we have minus a negative 5t squared is a positive 5t squared minus a positive 100t minus 100t. And now we can see what happens. The minus 5t squared is going to cancel out with the positive 5t squared. The positive 100t is going to cancel with the minus 100t. And lo and behold, everything that's left over has an h in it, which means that I can factor that h out. And cancel it out. And now with what's left over, I can plug in h equals 0 and get negative 10t plus 100. And so that's my velocity. So my s of t was minus 5t squared plus 100t. And now my velocity v of t is minus 10t plus 100. So now we're going to use that in later parts of the problem. Find and interpret v of 0, v of 5, and v of 15. All right. So v of 0, plug in 0 for t. That gives you 100. V of 5, plug in 5 for t. That's negative 50 and 10. That's going to give you 50. V of 15. That's negative 150 plus 100. That's negative 50. So this is the find part. Okay, the find part is plug the number in, get the number out. Now, interpret. That's where you have to go in and talk about what does this mean in terms of the journey of this model rocket. So first off, we need to figure out units. S of t was measured in what units? S of t was height in feet of the model rocket above the ground. T was measured in seconds. So S of t was measured in feet. T was measured in seconds. So that means that v of S prime of t, which is v of t, are going to have the units of feet per second, which is consistent in a velocity. So when we see v of 0 is 100, this corresponds to the rocket going 100 feet per second when t is 0, so at liftoff. And since this is a positive 100, this means the rocket's traveling upwards. So if we put all of this together, v of 0 equals 100 means at liftoff, the rocket was traveling upwards with a velocity of 100 feet per second. So that's the interpretation of that number. Next one, v of 5 is 50. Same thing. The 5 means we're 5 seconds after liftoff. The 50 means 50 feet per second. It's positive, so it's traveling upwards. V of 5 is 50, means 5 seconds after liftoff, the rocket was traveling upwards with a velocity of 50 feet feet per second. So initially it's going at 100 feet per second. 5 seconds later it's slowing down. Okay, so why is it slowing down? Because the gravity of the moon is pulling it back towards the surface of the moon. And I just noticed here, this more correctly at this stage, let's erase these words velocity here, because it is a velocity. The velocity is 50. The velocity is 100. But here we can be a little better. Was traveling upwards, so that we know the direction. Let's put speed in here. Upwards at a speed of 100 feet per second. Here we're still traveling upwards, so that's telling us the direction. And we'll put a speed of 50 feet per second. So the upwards tells us the direction, and then the number there, 50, tells us the speed. Speed plus direction gives us the velocity. Let's look at V of 15. Now that's negative. So this means that 15 seconds after liftoff, the rocket was traveling. Well, in this case, we get a negative velocity. So that's going to mean we're traveling downwards with the speed of 50 feet per second. So what comes up must come down. So at some point in between 5 seconds and 15 seconds, the rocket went from heading up to heading down. So we can kind of visualize here kind of what's going on with this rocket. You know, it starts off here on the ground. It goes up, and then it starts to fall down again. So initially t equals 0. It blasts off with 100 feet per second, and then sometime later it's starting to slow down, 50 feet per second. Then at some point it turns around, and then on the down, and then it starts heading down, and at 15 seconds now it's traveling downwards at 50 feet per second. So where does that rocket turn around? Well, that's the next question. Solve V of t equals 0, and what does this mean in terms of the rocket? So we've got a positive velocity and then a negative velocity. So if I look at my velocity V of t, negative 10t plus 100, when it turns around, it's neither traveling up nor traveling down. So when it turns around, the velocity is actually 0. And we can solve for that. T equals 10. So that means that 10 seconds after liftoff, the velocity is 0. So 10 seconds after liftoff is where the rocket turns around. So after 10 seconds after liftoff, the rocket turns around and begins to return to the surface of the moon. So if we think about it, ostensibly that's where the maximum height of the rocket is going to be. So the max height should happen when t equals 10 seconds. And so we could actually plug that in if we wanted to the s of t. So this would be negative 500 plus 1,000, so 500 feet would actually be the maximum height. So that's a way we could find the maximum height of the rocket. So that's it for example 3.